Hello everyone. Today we're going to look at multiplying some monomials, they're called, single terms, with some common bases and some exponents. And we're going to learn an exponent rule. What we're going to do is we're going to write numbers in different ways because sometimes different ways can serve different functions. So today we're going to learn multiplying with variables and powers, and we're going to learn to multiply monomials. They're called, with variables and number coefficients. You might have heard that word. You should have heard that word, coefficients. A coefficient is a number that's in front of a variable, multiplying the variable. So let's take a look at some of these. 5 to the second power times 5. And they call this the law of exponents. Well, if I remember, 5 by itself is 5 to the first power. That's an important important concept to remember, is that any number has a first power, or any variable has a first power if there's no exponent on it. So now if I have 2 5s here and 1 5 there, if I expand that out, I see that I have a total of 3 5s, or just 2 plus 1. They have a common base. That base is 5 in each of those terms. So now I can just say, well, this is 3 5s, or 2 plus 1 5s. And 5 to the third power, you can use your Desmos calculator and find out that that is 125. Or you could leave your answer as 5 to the third power, depending on what the question asks. It might ask you to leave your answer in the form with an exponent or an exponential form. And that's the law of the exponents for multiplying with a common base. Add the exponents and simplify. So you see when the common base is 2, the exponents are 4 and 3. So that means there are 4 2's here, 3 2's here. 4 plus 3 gives me a grand total of 7 2's. Works the same for variables. If I don't know how many a's I have here, and I don't know how many a's I have here, I do know that I'm going to put them together and add how many there are to get a total exponent for the a's. So let's look at a couple examples. 9 to the 6th power times 9. Remember that 9 has a first power, so my final answer is going to be 9 to the 7th power, 6 plus 1. 9 to the 7th power, I'm not going to multiply out the way I did 5 to the 3rd power, because 9 to the 7th power, massive number. 5 to the 4th times 5 to the 7th. Well, if I have 4 5's here and 7 5's here, how many 5's do I have all together? Add the exponents, 4 plus 7, and get 5 to the 11th power. Works the same for variable bases. As long as the variable is the same, you have to have a common base, the same base, C and C. So C to the 3rd and C to the 5th means I have 3 C's here, 5 C's here. Add them together with that common base of C and get a grand total of 8 C's, or C to the 8th power. This time with my base being a variable, there's nothing I can do to my answer. That's just my final answer. How about R to the 6th times R to the 4th times R to the 6th? Well, common base is R. If I have 4 in there and 6 there, add them together, I get a grand total. Sorry about the bell. Of R to the 10th power. P to the 3rd times P to the 9th. Well, common base is P. I got 3 there and 9 there, a grand total of P to the 12th power. Now, if I have more than just the number or just the variable, now I have to come up with a slightly adjusted rule. I have a negative 3x squared and a positive 4x to the 5th being multiplied. Remember, this negative 3 is multiplying these 2 x's, and this 4 is multiplying these 5 x's. So it's all multiplication between all of these things. So what you're going to do is you're going to regroup them. You're going to put the things together that seem like they belong together. The negative 3 and the 4 seem to belong together. So put them together as a multiplication problem. And the x to the 2nd power and the x to the 5th power seem to belong together. They're a common base. So put them together. And now just multiply. So there's your commutative and associative properties to put them together and regroup them. So now multiply negative 3 and 4. You'll get negative 12. And then the exponent rule for x squared and x to the 5th says add those two together and get negative 12 x to the 7th power. You try this one. You can pause if you need to. Okay, so negative 7 times 11 is negative 77. And the x's, exponents add 2 and 4 makes 6. Negative 77, x to the 6th power. And one more. Pause if you need to try it. Okay, negative 4 times 12 would give me negative 48. And x to the 5th times x to the 3rd gives me x to the 8th power because the exponents add together. So you multiply these coefficient numbers, but you add the exponents on the common base. What if I have multiple variables, more than one variable? Works the same, you just group together the ones that are the same. So group together that negative 5 and that 7 because they seem to belong together. Group together those x's. Group together the y's. Hey, check out this y right here. There's no power on that y. Remember, that's a first power. And group together the z's. And then multiply those coefficient numbers and add together all of your exponents. 3 and 5, 1 and 4, 8 and 2 gives me a grand total of negative 35, x to the 8th power, y to the 5th power, z to the 10th power. Last one. Pause if you need to think. All right, so negative 3 times 9 is negative 27. I have x to the 8th and x to the 1st. That'll make x to the 9th. I have y to the 3rd and y to the 6th. That'll make y to the 9th. And z to the 5th and z squared makes z to the 7th power. And that's how we write numbers in different ways.